This time, instead of giving an equation, we're going to give some conditions for a function and ask you to sketch the graph. And there may be more than one graph that will satisfy these conditions. But for this first example, we're f of 2 is 2. So on the graph, you want to put a 2 at f of 2. Go to the right up 2. And f of 6 is 4. So on the graph, you go over 6 up 4. So you have those 2 points. F prime of 2 and f prime of 6 are 0. So that means it's the horizontal slope at those points there. And the second derivative at x at 6 is less than 0. So it spills water at 6. And the second derivative at 2 is greater than 0, so that means it holds water. So then you just want to connect the dots in a continuous manner, and the answers may vary, but here I connected the dots here, so the function, this function will fit those given conditions. Okay. So another example, continuous function that satisfies f of 1 is 7. So put over 1 up 7. F of 5 is 2, so go over 5 up 2. The first derivative at 1 and 5 are both 0, so it's horizontal slope at those 2 points. The second derivative at 1 is less than 0, so that means it spills water. The second derivative at 5 is greater than 0, that means it holds water. And then connect the dots in a continuous manner. Okay, another example. F of 0 is 3, so I'm going to put over 0 up 3. F prime of 0 is 0, and the second derivative is less than 0. So that means it spills water at that point there. Also the limit as x goes to plus or minus infinity is equal to 0. So as x gets large in absolute value at either extreme, the slope gets closer and closer to 0, and then connect the dots, or connect the points in a continuous manner. Okay. F of minus 4 is equal to 9. Okay, so f of minus 4 is 9. Go 4 to the left, up 9. F of minus 2 is 5. Minus 5, rather. So go 2 to the left, down 5. It's 2 to the left, down 5. You get a point there. We have limit as x goes to 3 from the left is infinity, and the limit as 3 goes to the right is minus infinity. So that means we have a vertical asymptote at 3, and as we go for approach 3 from the left, it goes up and toward the asymptote, and as we approach 3 from the right, it goes down and toward the asymptote. The limit as x goes to plus or minus infinity is 2, so that's a horizontal asymptote. So we put the horizontal asymptote y equal 2, and as x approaches infinity, the function goes toward those horizontal asymptotes. And the function is continuous except at 3. I have a infinite, except at negative 3, we have an infinite discontinuity there. And that concludes this presentation.